Hello, and welcome to our initial installment of the Data Center Design Minute. I'm Mike Murphy, CEO of DVL. We're the data center strategy, equipment, and support experts in the greater Delaware Valley. In this introductory installment, we're going to discuss how to select the most cost-effective kW per rack selections for your data center. I'm involved in many early phase customer meetings where the issue of kW per rack selection as a design criteria for a data center expansion or a greenfield build is discussed. In my opinion, many times the selected design point is wasteful of capital dollars and strands power capacity in the electrical distribution system. So how do we avoid this problem? A short examination of the types of available rack PDU power connections will help us answer this question. First, there are a limited number of voltage and pole combinations available for rack PDU connections in a typical distribution system design. The voltage and current utilized by the rack PDU can be used to calculate the maximum kW available at the rack for that selection. For many years, the single-phase, single-pole 120 volt configuration was a standard connection in most data centers. This combination was abandoned for two reasons: third harmonic heating on the neutral conductors, which could cause fires, and a low kW per rack capability on the order of 2 kW per rack. With the advent of higher rack power density requirements, the adoption of 2-pole and 3-pole 208 volt connections at the rack has become common. For medium density applications, 20 amp and 30 amp connections are typically used. Higher power density connections utilize 50 and 60 amp connections. These are demonstrated by the power strip behind me and can offer as high as 17.4 kW per rack. For higher power density applications, more and more users are looking at utilizing the European voltages of 230 volts line to neutral and 400 volts line to line. With these connections, it's possible to deliver up to 34 kW per rack in a single power strip. However, careful consideration has to be given to the fault handling characteristics of the distribution system to prevent damages and fire from short circuits. In conclusion, end users should use the voltage and amperage ratings of commercially available rack PDUs to select the kW per rack design point. Also, a single rack PDU per distribution system should be used to minimize cost. This practice avoids wasted capital and reduces the potential for stranded capacity. For a more thorough discussion of this subject that includes all available kW per rack design points, please visit our website at dvlnet.com/chapter 1 and register for a free copy of the first chapter of our upcoming manual on data center design. For helpful additional advice and information regarding data center design, visit dvlnet.com, email us at info@dvlnet.com, or call 215-785-5950 to schedule a consultation with one of our data center experts.